So, hi and welcome to this next session at Techorama. My name is Rainer Stropek and I'm really glad to be back here in Belgium. It's always a pleasure to present at this awesome technology conference. And today I'm going to deliver my first session here. Will be a special session because I promise you to do no slides and just demos. And this is what we are going to do. The topic of the next upcoming hour is asynchronous programming with JavaScript and TypeScript. And this is what we are going to do. We are going to write a lot of JavaScript and TypeScript code and analyze the different options that we have. We are going to start with a short example where we could say it will be a little bit of a callback hell. So what is the previous state in the JavaScript world concerning async programming? And then we are going to make it better. We are going to introduce promises. We are going to deep dive into async await. And we will take a look at ReactiveX, Rxjs, and take a look how Rxjs can make async programming easier, and especially how it is applied in very popular large-scale frameworks like, for instance, Angular. This is what you are going to see in the upcoming 60 minutes. So, let's go directly into Visual Studio Code, and we will not leave Visual Studio Code for the next 60 minutes. I have set up a small sample startup project here, and it's not that important, I've recognized that people like to see the tooling that I set up here. What you see here is a very simple Node.js program. Currently, it just says, let's get started, nothing else. And if we take a look at package.json, and if we zoom in a little bit, you will see that for this demo, I'm going to use Mongodb, Rxjs. I'm going to program in TypeScript, but no, don't worry. If you're interested in the JavaScript code, you will see the JavaScript code too. And I'm going to use some tooling. I'm going to use Nodemon and concurrently so that I do not have to start the Typescript compiler over and over again. So, on the right-hand side, I'm going to start Nodemon. And if we zoom in a little bit, you will see that in this setup, it always says, let's get started. And if we change something and save it, it's automatically restarted and ran on the right-hand side. So whenever I change something on the left-hand side, we can always look at the example on the right-hand side. I decided to focus on the languages, and therefore I'm not going to go into the browser. So we are writing Node.js code, but you could take exactly the same code and run it in your browser. So if you are not that much into Node.js, but more into the browser development, don't worry. All the knowledge that you gather here in this session is applicable to the browser, equally so as in Node.js, what I'm going to show you here. In order to save us some time, I have already added some import statements, and we have to talk about them. Let's get started. The problem that I would like to focus on in the first few minutes is this one. We have a task. We are a fictitious developer in a company, and our task is to do some work with Mongodb. If you're not familiar with Mongodb, no problem. Exchange it in your mind with SQL Server or any other data store that has an asynchronous API. You could also imagine if you're a web programmer, you have to access some web API sitting on, I don't know, in Azure or something like this. So what we would like to do is we would like to open a Mongodb database. We would like to read all the persons with last name John. And if the person is a customer, here you see that one, we have to gather some more detailed data in a separate data store. In that case, we have to go into the customer collection and get the customer details. And if the person is a supplier, we have to go into the supplier store, fetch some details there. And at the end, when we have processed all the different persons, we have to close the database. Not a different task? Well, let's take a look. Before we take a look at promises at async await, it's always good to understand what the problem is. And therefore, I would like to write a few lines of code in classical JavaScript without promises, without async await, with callbacks, and understand why the current situation isn't that nice. So, I've prepared some snippets, and the first snippet that we are going to use is that one. This snippet, let me zoom in a little bit so you can see it better. This snippet does nothing else than connecting us to a Mongodb database. As I said, if you are not a Mongodb programmer, absolutely no problem. You will understand the code. The point that I would like to emphasize is that one. The method connect takes a callback method, and that's very, very common in the JavaScript space. And what we get back is an error object and our client, our MongoDB client. And inside, in this case of the Lambda method, we see that here, we can now work with the client and do some error handling. We will not discuss error handling here, just to keep things simple. It would even make things worse if we would add error handling, but to keep things simple, we will skip error handling for the moment. So here you see a callback, but up until now, that's not a big issue. The next thing, what we need to do is we need to connect to our person collection. And it happens that MongoDB, let me zoom in again, that MongoDB offers a method which is called collection, and guess what we have to give this method? We have to give it a callback function. So we have the next nested callback inside of the code. Once we have connected to the person, we can do a find. Inside of the persons, we will look up all the persons with name John, and we will get an iPerson object back. Let me quickly copy in some interfaces, so we have some IntelliSense here, no problem. By the way, of course, I provide you with all the samples, so if it's too fast and you want to, at home, you want to dive deeper into the code, that's absolutely no problem. At the end of the session, I will give you a link to my blog. There you can find the sample code, and you will also find the recording of this session, so you can recap what you saw here. Let's go back to our example. What we see here is the method toArray. The method toArray is really executing the query, looking up all the persons with name John, and the point again is that we have to provide another callback. So this time we are 3 levels down into callbacks. And if we remember what we wanted to do, it was a very simple task. We just want to open the connection and read all the persons with John. In the real algorithm that we want to express, we don't see any callbacks. We don't see any nesting. That's the problem with all these callbacks. The next thing that we can do once we found the persons, we can go through all the different persons. So what we can do here is we can make a loop over all the persons, just a for loop over the results of the person query, and then we can do an if statement where we check whether the person is a customer. And guess what? If we want to read additional data about the customer, again, we have to do some querying. In that case, we have to query the customer table again. We have already seen that, and I think by now you got the point. We have another callback method here, and once we got the customers, we can do a detail find customer collection. I get back an iCustomer, and what you see here is another lambda here. In the find one, we have another lambda, and at the end, we finally have the results. And if we do the same down here for the suppliers, we can try to run our application. Let me quickly finish that. So we will go to the suppliers here, and then we will say, go to the, look up the supplier by the supplier ID. You get back an iSupplier object. And now we have our algorithm nearly done. Let's quickly take a look at the algorithm. This was our task. Open the database, read all Johns, make a loop, read additional data, and print the result. Can you see the algorithm in this code anymore? This is why people call JavaScript sometimes a callback hell. Because of all these callbacks, you do not see the underlying algorithm, the intent that the programmer wanted to express with his or her code. We can make things worse, because if we take a look at the end, when everything is done, we want to close the database. Where should we put the close statement of the database? Of course, what we could do here, we could, for instance, take a look, where is the end of the for loop? It is here. We could say client.close. But if we would do that, our program wouldn't work, because this close statement would be executed immediately before these collection statements and find one statements are executed, because they are executed in an asynchronous manner. So what we have to do is we have to close the database somewhere in here. But the problem is we cannot close the client here because additional Johns will come. So the program gets even worse, because what we need to do is we need to define some additional code. Let me show you what I mean here. We have an additional lambda with a counter that's calculating how much rows did we already process. And at the end, we have to call this method over and over again, something like this, and something like this, in order to make sure some kind of ref counting is going on here, in order to make sure that the database is closed properly. Let's quickly try this thing. I restarted it, and oh, we get, I see. What I did here is I switched the wireless LAN, and I'm running my MongoDB inside a Docker container. And unfortunately, if I switch the wireless LAN, my Docker for Windows has to be restarted. We will not wait until that restarted. It will be restarted in 2 minutes or so. I will restart my Docker then, and we will see that this program really works. The point of this program is that the algorithm isn't visible. The intent isn't expressed properly. So this is definitely not the kind of code that we would like to write in 2018. Code that we write in a modern programming language in 2018 should look different. Of course, there are tools in the JavaScript land space, like the Async package, that can make things a little bit better. And in large scale, you would probably restructure the code by giving these function names and things like that. But at the end of the day, you can do whatever you want. The code will never become beautiful. Okay. So it already restarted. So let's start our Mongo. Here it is. Rerun it. And now you see it really works. Once we have our MongoDB running in Docker, John Smith works as Acme Corp. This is the customer, and John Turbo works at Worldwide Importers. This is our supplier. So our program works fine, but it is not beautiful. Up until now, I only showed you problems, no solutions. Now we are switching gears, and we are going to talk about the beautiful new future that we live in modern JavaScript and TypeScript land. We are going to change this implementation, but this time we are going to implement it in a way that you should work in 2018. Let's get started by connecting to the database in an asynchronous fashion. And the point that I would like to point out is this guy here and this guy here. I bet there are a few C# programmers in the room too, people who write C# and JavaScript or TypeScript. And if you are a C# programmer, you will definitely immediately recognize these two keywords, async, await, and you will immediately understand what they do. For those of you who are purely from the JavaScript space and have no idea about C#, let me quickly introduce these two keywords. The first one, the async one, marks a function so that it can contain the await keyword. And the await keyword that you see here stops the execution at the point where await is inside the code, and it will resume the rest of the method once the async method has been completed. That's the very important thing here. So if you take a look at our, for instance, connect method here at the end, there is no callback anymore. Goodbye callback, we don't need you anymore. No callback hell anymore, because now we have async await. And it's the same here with the close statement. We can await the close statement, and the very important thing is we do not have the nesting anymore. The code is now sequential, and the code is much better suited to express our intent. Let's quickly recap what our intent is. We want to get all the Johns, loop through them, get some additional customer data. Let's finish this thing. If we do the next step, we can say open the person collection and do the finding. We look for all the Johns, and you see the code now looks really pretty much as we want it to look like. If I zoom in a little bit, you see no nesting anymore, no callbacks anymore. Whenever we want to execute an asynchronous method, like here for instance, here we want to execute the database query. As I said, if you're not a MongoDB guy, no problem. Imagine this would be a SQL Server call, or if you're on the client side, this would be a web API call. No callbacks anymore. We just say await, and we beautifully get back, in that case, all the persons. Now that we have this person object, we can do the loop. And this time, if you take a look at that guy, this is the opening, this is get all the Johns, this is for all the persons. And if you take a look at the algorithm in our conceptual document, it really looks like the code. It reflects our intent very well. Now, if it is a customer, we'll go to the customer collection and we can find and print the customer by its ID. I think by now you got the idea. Let me quickly finish it so we will see that it really works. Then in the other case, the guy is a supplier. And it should look up the guy based on the called supplier ID. Let's quickly save this guy, and if everything works out nicely, you will see it here that it perfectly works fine. But the code looks very much different to what we had before. We no longer have this callback hell, we no longer have this nesting, this callbacks and callbacks and callbacks, and the code, as I said, I repeat myself consciously, expresses our intent, is easy to read and easy to maintain. Now, of course, in a technical conference like that, we do not stop with this, I always call it Harry Potter programming. It's a little bit of magic, a little bit of fairy dust inside of the code, and something magically things start to work out. We want to know what's happening behind the scenes, and we want to understand how this thing works in the background. And this is what we are going to do in the next few minutes. So, let's first take a look at one of the methods. Let's take the find one here. And if I do that one and I zoom in, what you will see here is the structure of the MongoDB API here. You see the find one method returns something which is called a promise. For those of you who come from the C# and .NET world, guys, this is a task. Okay? In C# you call it task and you can async await. In JavaScript we call this thing a promise. It is a promise that at some time in the upcoming future there will be a result for us, but the result will be gathered asynchronously, so it is a promise into the future. This is what we have as a promise here. And MongoDB, I have chosen the MongoDB API here because it is a good example for a very nice pattern. If we zoom in now, you will see that this method has multiple implementations. And one of them returned a promise. The promise is returned if we do not pass in a callback. But we always can work with a callback if we prefer. For instance, if we have existing code that has been written prior to async await and promise land, ECMAScript 3, ECMAScript 5, something like this, we will probably have a lot of MongoDB, Web API, SQL Server, whatever code that relies on having a callback. And so each method, each async method of this modern version of the MongoDB API recognizes automatically whether we give it a callback or not. If we don't give it a callback, it will return a promise that we can wait for. If we pass in a callback, it will call the callback and we do not have promises in the play. Okay? And as I said, many APIs that you find out there, for instance also the one that accesses SQL Server, MS SQL and so on, they follow this pattern of giving you the option of working with callbacks and promises. So what are these promises? Let me quickly deactivate this part of our sample and go to the next sample. In the next few minutes, I would like to spend some time with you diving into some interesting properties of the promises. Okay. To get us started, I wrote two methods. Let's spend a few moments discussing these two methods. Let's start with this upper one. It's a very, very simple method. It's a division method. You pass in x and y, and it returns x divided by y. No problem. Imagine that this would be a more complex algorithm doing some fancy calculation that also requires some async methods like fetching data from a database, a data store, or whatever. Imagine whatever fits to your domain. The second one, but is exactly the same method, but in that case, we are simulating some more complex thing. To keep things simple and to allow you to follow the details and the concepts, I just simulate some async work here. I'm using the set timeout method, and I'm just waiting 250 milliseconds. So please use your imagination, and here where we have this set timeout, for your domain, it might be, as I said, a web API call or whatever. The point that is important here is that our new implementation now returns a promise. It returns a promise that we create here, and when we create the promise, we have to give the promise a callback method, a method that the promise constructor will call, and it will give us, let me get rid of the markings here, and it will give us two methods that we can later on asynchronously call to tell the promise back whether we have a successful result, resolve, this is this one here, or whether we have an error, reject, this is this one here. So let's take a look at the implementation. As I said, we are simulating an asynchronous implementation with a set timeout here, but after the 250 milliseconds are over, we are calling either result or reject. Resolve, sorry. Resolve means we were successful, here is the result. This is okay if we get a y value which is not 0. We call reject if we have an exception. So we do not throw an exception here. If we work in promise land, we have to reject the promise. And therefore, we are talking about a resolved promise or a rejected promise. And we will take a look in a few minutes how we can do proper error handling with these promises and how this error handling also plays nicely with async and await. Now let's use these two functions. Let's write a little bit of code. I'm just embedding it here into a small anonymous function. And if we want to use the promises here, let's quickly build an async function. Let's call it, oops. Let's call it run, async function. Let's call it run, something like this. And then we will call the run method. Yep, this looks good. Now let's call the diff async. If we want to call the diff async, we can do it as usual. For instance, something like this. This will, of course, result in 42. And if we want to do something once the promise has been resolved, we can do that in a functionally manner by calling the then method. So this is promises combined with callbacks. We are providing a callback here that will be called when the promise is resolved. So we can do something like this. X will be the result, and we say console log x, console, and if we save this guy, it should return, yep, 42. So we called the async method, and we used the then method as a callback. Of course, we can now use async await instead of the then because we do not want to use the callbacks anymore. So now we can say await diff async 84.2, and we can do a console log around the await statement. So await plays nicely with the promise, and it replaces the need for the then call with the callback. If I save this guy, you see on the right-hand side, the results are the same. One is doing the processing with the then call, and the other one is doing the processing with the await call here. We can also concatenate or do these asynchronous calls in sequence with the then and the async method. I mean, with the async method, it's trivial. We just write async method call, async method call. But with the then, it's not obvious, and therefore I would like to show you that. If we say diff async, and for instance we say 186 by 2, then we can process the result, as we have already seen, with the then method. And inside of the then method, we can do another asynchronous method where we divide x again by 2, and then we can write the next then statement. So we can put multiple of these then statements in a kind of sequence, and the API, the promise API, will go through them sequentially, one then after the other. So if we say then again, and if we say x, and we say console log x, for instance, and if we save this guy, we should see 42 3 times, because this is exactly what we do now. But the third one is a sequence of asynchronous statements expressed with multiple then statements. What about errors? In real world, we have to add some error handling. I forgot one thing. I've just taken a look at my notes before we go into errors. What can we do if we want to execute multiple asynchronous implementations in parallel? For that, the promise class offers us some very interesting methods. For instance, the all method. If we say, let's execute all the promises, and let's do something like diff async 84.2 and do that 2 times. Now, the important thing here is that these 2 asynchronous methods, imagine this could be database queries or web API calls, these 2 asynchronous methods are now running in parallel. And the promise API will wrap another promise around these 2 async methods so that we can await this guy on the outer API call. So now we run 2 queries at the same time and await both of them. Of course, there are other utility methods in the promises API. I'm sure you will find out about them if you take a look at the API docs. So if we say something like, I don't know, console dir, something like this, and save it, we should again see some result. And here you see the result. It's an array because we executed 2 asynchronous methods at the same time, so the result will get back an array of results, and we print the results, and here it is. It works perfectly fine. Now to the promised error handling. How can we do error handling? What we can do, if we say diff async, for instance, 42 divided by 0, we can do a then, and in the then method call, let's go here, we can provide 2 callbacks. You see that one? The first one is called if the method was successful. The second one is called in case the promise was rejected. So in my case, it will be rejected because I'm trying to divide 42 by 0, and that, of course, doesn't work. Just to refresh your memory, here you see we had this if statement here, and if y is 0, it will be rejected. So if we do that one, we could say in the first method, x goes to x console log x. And in the second thing, we say, for instance, what could we say? Error goes to console.error, error, something like this. And if we run this guy, we will hopefully see exactly division by 0. This division by 0 comes from our error callback that you see here. So we can provide a callback method that is called in case this thing is rejected. The powerful thing is that we can even do that if we have multiple of these methods, for instance. So if we do something like this, if we copy this guy from up there, something like this, and in this case, in the second one, we have a mistake, then we can use the second method of the promise instance, which is a catch statement, and in the catch statement we are going to catch the errors. The important thing here, if we take a closer look at this structure, is that this catch clause is called whenever an error appears somewhere in the sequence of promises. So if somewhere in the middle something goes wrong, the catch method is called, and the rest of the then sequence is ignored. Okay? It's kind of exception handling expressed with functions based on the promise API. Okay? This is what we can do with this API. How does error handling now work with async await? What happens if we do await div async 42 by 0, something like this? Let's just try it and take a look what's happening. And here it is. You see, we have an unhandled promise rejection warning that says, hey Rainer, we have a promise rejection, you await for a result, but I don't have a result for you because we have a mistake and we have an error here. So what we can do about that? And the solution is a good old friend, try catch. So the beauty of async await in terms of error handling, oops, there it is, catch error, and do some console.error, error. Save this guy. And now we should see, very nice, we should see our divide by 0, and this division by 0 comes from the exception handling of our async await code. Let me quickly zoom in here a little bit to recap what we did here. I was a little bit fast, and therefore we want to quickly take a look at this code. You see, this div async method, can you remember? It returns a promise. This promise is going to be rejected because we passed in a y value of 0. Remember that we didn't throw an exception inside of the asynchronous method. We just rejected the promise. The await statement here, in this thing here, this await statement recognizes if the returned promise is rejected. And if it is rejected, it's going to throw an exception. And this exception can now be caught with the try catch statement. So this is really nice because if we have multiple of these statements, we can write the code as we intended to write it. So something like this, and again like this, and if somewhere in the middle, somewhere here, an exception is thrown, the exception leads us into the catch clause, and it will handle the error hopefully gracefully, and then everything is fine. Well, hopefully everything is fine. Okay? So let's save this guy and check whether it works, and I'm quite sure it works. Yes, it works very nicely. Maybe you ask yourself, let me quickly remove that guy here, and let's bring back our second example with the async await code here again. Something like this, and save it. Maybe you ask yourself, well, Rainer, that's all very nice, but we have to deal with some old browsers that do not have the latest and greatest JavaScript enhancements available, and we also do not use TypeScript like you do it here. What can we do? Well, let's take a look what's happening behind the scenes. We currently do not need our terminal, so I'm going to close the terminal. On the other hand, I'm going to take a look at the result that TypeScript creates for us. And what you will see on the right-hand side, let me quickly take this one. Yeah, this is the right one. If you take a look at the left side, this is the site, this is the TypeScript code, and this is the JavaScript code that TypeScript creates in the background. And as you can see, this generated JavaScript code does not at all look like the code that we wrote in TypeScript. So what's the point? If you program in JavaScript, can't you use these features? Well, no, you can't if you are using an older version of JavaScript. If you are, for instance, using ECMAScript 3 or ECMAScript 5, you do not have async await available. If you use ECMAScript 3, you do not even have promises available. Of course, there are polyfills and things like that, but at the end of the day, the JavaScript land isn't that beautiful in the old versions of the language. But gladly, we have our good friend TypeScript available. And TypeScript, if you do not use TypeScript, by the way, and you just want to stay with the JavaScript parts, no problem. Use a component which is called Babel. If you use Babel, you can do exactly the same with pure JavaScript. You do not need TypeScript for that, absolutely. But I decided to use TypeScript here because I write nearly my entire JavaScript code in TypeScript, and the TypeScript compiler has an option here, which is the target. And based on the target, the TypeScript compiler will translate promises and async await to the proper JavaScript code, which might be very old, from the Stone Ages, ECMAScript 3, rather old, ECMAScript 5, or pretty new, ECMAScript 2017, or something like this. Let me quickly show you what I mean with that. If I change this to ECMAScript 3, and we have to stop it here, so npx tsc, something like this. This calls the TypeScript compiler. Now the TypeScript compiler is through, and if we take a look, you will see at the beginning a lot of generated code. Here you see some generated code which is called __ generator because in the background TypeScript emulates promises and async await using generators, but with ECMAScript 3 we do not even have generators available. So this code is really very, very ugly if you take a look at it, and thankfully, we do not have to write it, because TypeScript is doing the heavy lifting. And if we get a newer browser, we can switch to ECMAScript 5, recompile this guy, and we will see that some code goes away. But the point that I would like to show you here, if I go to a very new version of JavaScript that we target here, and if I scroll down here, now let's get rid of that guy. Let's take that one again. Let's get rid of that guy and do some drawing again. Now compare the TypeScript code on the left-hand side with the JavaScript code on the right-hand side. Do you see what you have here? You have async, you have await. So in JavaScript, it depends on which version of JavaScript you would like to target. If you have control over the environment that you are using, maybe if you work in an enterprise environment where you know that your web app is running in the latest version of the Chrome browser, then this is a very good option because you can target ECMAScript 2017 and Chrome will immediately recognize async await. If you use Node.js and you know which version of Node.js you are targeting, then you know that your version hopefully supports async await, so you can target something like ES 2017. However, if you have to provide code that runs in very old browsers, like for instance versions of Internet Explorer that do not support async await, that do not have promises support and things like that, then you can do this transpiling, and TypeScript will translate async await promises, generators, and so on into old, let's say, JavaScript code. And as I mentioned before, if you do not use TypeScript, use Babel to achieve the same result. Okay? Very nice. Of course, you could also provide multiple versions of your application from the same source code, an old one and a new one, depending on your scenario. I mentioned before the whole sample that we did up to now is available on my blog post that I will show you at the end. So if you want to dive deeper into my examples, do some debugging and things like that, no problem. You can fetch it from my blog. So let's get rid of that example. We don't need that one. We don't need that one. And let's get rid of that example here. Okay, nice. Let's open a new chapter. We have approximately 15 minutes left. And the last 15 minutes, I would like to switch gears. So, breathe in, breathe out, now to something connected but quite different. There is a very popular library out there that is an alternative to all these things that I have shown you up until now. And if you want to work with Angular, for instance, like I do a lot of Angular development workshops and things like that. If you work a lot with Angular, you will not see async await very frequently. You will not see promises very frequently. You will see something else. You will see reactive extensions, Rx, instead. And I would like to introduce you to Rx and discuss in the final 15 minutes now why there is room for a completely different approach and how these two systems, async await with promises and observables, which is the main data type of Rxjs, how they come together, how they play together. Okay, let's start with the basics. Rx basics. Okay, let me zoom in. And, oops, I don't want this here, and go here, and, yeah, this is exactly what I would like to show you. Now, the most important data type that you get from Rxjs is an observable. An observable is a thing that you can observe. So the observable will give you some asynchronously gathered results whenever it has them. And it will push the results to the so-called observer. So the observable is executing asynchronous code, like executing a database, like calling a web API, and of course you can use Rxjs in Node.js on the back end, and you can use Rxjs in Angular or plain JavaScript on the front-end side. It works everywhere. So the observable will push the results to the observer, and the observer is your application, your Angular front-end or your Node.js code that is sitting there and waiting for the database results. At the lowest level, you have a method which is called create. It creates an observable, and what this create method gets is a method, a callback method, that receives an observer, and with the next method, or the error method, or the complete method, you can push your asynchronous results to the observer. So the observable that is doing some asynchronous stuff receives some results, and whenever it has a result, it can say, hey, observer, I have something for you. Here it is. And it can be a result, an error, or the indication that we are done, that there will not be any further results here. This is the main concept of the observable, and the most important difference at the first that is obvious if you take a look at this code is that an observable can return multiple results. With async await, we are awaiting a single result, a database result set, an object from a web API. We are awaiting one element, while an observable, a connection between an observable and an observer, is something that lasts. How long? Well, we will discuss that. It can be forever. I can say, hey, dear, let's say, button on a web form, inform me, I observe you, inform me whenever the user clicks, and the connection between the button and the observer can be for the lifetime of the application if the button will stay on the screen forever. But nobody forces us to work like that. An observable can also return a single element, and then the difference between an observable and async await, the promise, is not obvious anymore. Why not using async await and promise instead of an observable if we just return a single result? Imagine you are calling your web API, get customer, and you know that you will return, that you will get exactly one result back, the HTTP response. Why bother using an observable? Well, keep this question in mind. I will answer it in a few minutes. At that point in time, we just remember that observables are capable of delivering multiple results. Now, how does the consumer side look like? Okay? This is the consumer side. Here you see an observable. This is the observable that we created above, and we have a method which is called subscribe, and we can give it 3 callbacks, next, error, and complete. And I think the names speak for themselves. I do not have to describe what they essentially do. And in our case, the subscribe method will lead to multiple calls to the next method, because whenever up there the next method is called, this callback will be called. And if the complete method is called, the complete callback will be called. And of course the error, I think you get the point. Okay? An important thing that you have to remember is that an observable without then a subscriber doesn't execute any code. So if you create an observable like here, and nobody is interested in the results, nothing will happen. The next will never be called. And this is important if you, for instance, use Rxjs in Angular to execute an HTTP post. You might think that the HTTP post is a fire and forget and I'm not interested in the result. I hope it will work, but if it doesn't work, I don't care. Just send the post, and you just set up the observable, and you never call subscribe because you are not interested in the result. Guess what's going to happen? The post will never be sent to the server because nobody is interested in the result, and therefore the observable will never start. Technically, this callback function will never be called. Okay. Now these were the basics. Let's take a look at some more interesting stuff. For instance, this one. Here we see that the beauty and the power of Rxjs is not just the implementation of observable. The real beauty and power of Rxjs are the utility functions that come with Rxjs. Here you have a bunch of them. For instance, these two here, off and range. The off method takes, in that case, 3 numbers, and guess what it does? It creates an observable that is pushing our 3 numbers, 1, 2, and 3, to any observer. So the first line that we see here will just print out on the screen 1, 2, and 3. You have another utility method, range, which does exactly the same, but you do not have to specify all the different numbers. For those of you in the audience who are experienced C# developers, can you remember that? Does that ring a bell to you? Enumerable.range, things like that, very similar concept. The next line is even more interesting. What you see here is an observable that is created by a timer. So Rxjs contains a bunch of creation methods that you can use to set up an observable without having to specify the values. You can define a timer as a source of an observable. You have an integration into the DOM, so you can take an event from a DOM element like a button, and you can create an observable from a button event. Whenever the button is clicked, send me a message, push something to me. I am the observer of this observable. And then you can combine these creation functions with a so-called pipeline. So you can take the elements that you get from the observable and put it through a pipeline, and you have dozens and dozens of operators. In that case, we just have a single operator, take 3. That means take the first 3 elements from the observable and then close the observable. I'm no longer interested. Things like filtering, a where clause. Things like projecting, a map function, where you can exchange one value with another value. All these things are available, and even more way more interesting ones that I will show you at the end of this talk. So the power of Rxjs, why many applications prefer, or let's say combine, async await and promises with Rxjs is not just the concept of the observable, but it is the powerful collection of creation and pipeline functions that make it super easy to create stunning results with asynchronous programming with exceptionally little amount of code that you have to write. So this is the power of Rxjs, and if you want to dive into Rxjs, you will have to reserve some time to understand and look through the documentation to see and understand all the different functions and operators and so on, and believe me, it will be a nice world that you're going to enter. Observables also combine very nicely with the world of async await and promises. Because in that case, for instance, the for each function from Rxjs, what it does, I think it is obvious. Yeah? For each element that I get from an observable, I execute some function, in that case a console log. For each, for instance, is something that provides at the end, you can see it here, a promise. And we discussed promises before. So we can await a for each method and execute code once all the observable results are processed. So observables and async await and promises, they are not contradicting each other. You do not have to choose, I use only observables or only promises with async await. On the contrary, they play nicely together. And whenever you have an observable like that, you can also say, you have it here, to promise. So if you already maybe have asynchronous code with async await, and it happens to that you use a library like AngularJS that gives you an observable, but you prefer async await because you are so used to this concept and it makes you productive and feel good and whatever. Don't worry, just say to promise, and then you are building the bridge from the observable Rxjs world into the promises and async await world. Okay? I imagine that in the back of your heads, some questions are going through. Something like, hey, is there nice exception handling available? And is this compatible? And is this well maintained? And things like that. The answer is yes. So Rxjs is not a niche library that maybe, I don't know, a bunch of people in this whole world use. Rxjs is a mainstream, large, well-maintained library. And the best thing why I like Rxjs so much is Rxjs, as the name suggests, is just one implementation of reactive extensions. There is an Rx for .NET. There is an Rx for dozens of languages. So if you work like I, for instance, if you work with C# in the backend on your server, .NET Core, for instance, and TypeScript with Angular on the front end, once you understood Rxjs, you have the same API available in C# and in JavaScript or TypeScript, as you can see it here. So if you dive into Rx, you can apply the same knowledge to multiple platforms and programming languages. And I personally think that this is a very nice thing. We only have a few minutes left, and I would like to switch to, oops, this is the wrong one, this is the right one. I would like to switch to a final example that shows you how observables can become even more useful. What I have here is a nice little application. Let's switch to something like this, and let's zoom in a little bit, something like this. And if I type in some code, you see, it's just an autocomplete combo box, as you can see it here. If I type BMW, something like this, and it looks up some car makes, as you can imagine. Now, this little Angular application has a lot of functionality. What does it do? First, maybe you recognize it by looking at the network stack on the left-hand side. If I type very fast, oops, it does not fire a web API call at every keystroke. It waits for 250 milliseconds, or a definable amount of time, until I stopped typing, and then it looks up the code, the make in that case. The second thing that it does, if I, for instance, do a TO and then a Y, oh, I was too slow. Let me try it again. TO and then a Y. I was again too slow. Come on. I can't produce it now because the network is so fast. Typically, I present in conferences where the network is really slow, and it's easy to show the point. But believe me, what the application does, it's sending the HTTP request to the server and says, give me all the makes that start with TO. And if I then continue typing and the first request isn't done yet, it will cancel the first request and send a new one if I changed my mind and continue typing. So if you think of how this functionally rich autocomplete combo box if you would have to implement that without having something like Rxjs, you will probably come to the conclusion that this isn't a trivial task. And now I would like to show you the power of Rxjs by taking a look at this implementation. The only thing that implements the whole thing is this one. And let me quickly analyze what we see here. Angular.js allows you or gives you an observable value changes that is connected, or that you can connect to any input field. So what Angular does, it's connecting Rxjs observable with an HTML DOM input element, and it gives you an observable that you can observe. And whenever I type something in, it will send me a result. So we see an input element as an asynchronous I/O operation. But in that case, we are not accessing a database, but we are waiting for the user to enter something. Then we can take these keystrokes from the user and put it into a pipeline. We can use an operator starts with that tells the whole pipeline that even if the user doesn't type anything, it should simulate an input of an empty string as the initial value. You know why I do that? Because I immediately want to open up the autocomplete combo box if the user enters the field. Next, I use an operator, debounce time, which cares for stopping the observables if they happen to come in very fast. So debounce time waits until the observable has stabilized for 250 milliseconds and then passes on the last observable. And the last one is the switch map, where we exchange one observable with another observable. So the observable coming from the input, the user typing on the keyboard, is changed with an observable that represent an asynchronous HTTP GET operation calling, in this case, a service in Azure. And you know what this switch map does automatically? They cancel previously sent observables. So previously sent requests are cancelled so that they do not consume any CPU or I/O or whatever you want. So the whole implementation of this quite nice autocomplete combo box fits in a single line where we combine two observables with a pipeline. And I think this is a very nice example that shows the power of async programming with Rxjs. So, time is flying, and we are already done. So, I promised you a blog article. It's here, just software-architects.com is my blog. You do not have to remember the whole URL. Just go to software-architects.com. It currently is the topmost article. I recorded this, so I will add a YouTube video at the end of this session, so you can refresh your mind once you have left the Techorama, and maybe you would like to dive deeper into my samples. I would love to do that. I want to say thank you to you all for coming. I hope it was interesting to see a little bit about async await, promises, and Rxjs in the modern JavaScript world. Thank you for coming. I wish you all a very nice Techorama, a very nice day. Yeah, enjoy the conference. Thank you very much.